Hey guys, my name is McCall Atchison and I'm a professional welder. I'm based out of Hartselle, Alabama, but I've come up here to Sanctuary to teach an intro to basic steel welding with the SMAW welding process. Alright, you ready to go? Alright, so my name is McCall Atchison and I've been welding for about 5 years now. My background is in the aerospace defense fabrication side of the industry, so I have experience on the Patriot missile system, the Hellfire missile, and SAW machine gun parts. Mostly all I did was aluminum and stainless steel and chromoly, more exotic metals. But today we're just going to get you started on the most basic thing I can teach you, which is SMAW, also known as stick. So SMAW stands for Shielded Metal Arc Weld. So SMAW is the oldest process of welding that uses an electrical arc. There's welding throughout history, blacksmithing is a form of welding, forge welding. So if you get like Damascus steel that's been folded and pounded up on each other in layers, that's a form of welding. But welding has evolved to where we use an electrical arc. So, SMAW, shielded metal arc welding. So the reason they call it shielded metal arc welding is because of this electrode. So, as you can see, you have a metal core and then this powder on the outside. So this powder is called flux. So as this rod burns, this flux turns into a gas and shields your molten metal from the air we breathe. It doesn't like it. It causes porosity, which is pinholes in the weld, and it can cause all kinds of defects. And then it also turns into a slag, which is it's almost like a ceramic feeling coating on top of the weld that you actually have to break off. So you have two forms of shielding. You have the flux that turns into a gas and your slag. So that's SMAW in a crash course. Let's talk about polarity for a second. So on my machine, my machine actually doesn't have it, but usually you'll see a positive and a negative. Mine, it just says work for the negative, which is your ground, and I think it says, TIG stick for the positive, which is your actual electrode. So let me draw a little something. So this is our welding machine, okay? So we'll have a negative and a positive, and this is our workpiece. So our ground, which is this, will be hooked to the workpiece. And then our electrode, which will be coming out of the positive side, is what our rod is going to be held with, which is this. People will also call this a stinger. It's just a slang term. But you'll literally clamp this on your rod, and that is how you're going to deposit metal onto your workpiece. So this welding current can travel hundreds of yards. So if we were on like a construction project, like up in scaffolding or something, I could clamp this at like the bottom, climb up 3 stories, bring this with me and still get flow. It goes far, especially with stick welding. So this polarity is called reverse polarity, and that's important. Because you'd think that our electricity is flowing from our stinger to our workpiece, but it's actually the opposite way. Our electricity is flowing from our workpiece to our rod. So that causes the transfer of metal back to it. So it's actually called, the technical term is globular transfer. So if you look at it under a microscope, It's tiny little droplets that are falling into the molten puddle. So that's polarity. So let's talk about our rods. So this rod I've been showing y'all is what's called a 7018. There's thousands of different kinds of rods, but the two most common and what y'all need to have in y'all's toolbox is a 7018 or a 6010 or 6011. 6010 and 6011 are about the same rod. 6010 is a little newer, and that's what we're going to be using today. So why are they numbered? So I'll go over that little number scheme real quick. So the 70 is our tensile strength. So the 70 in 7018 stands for 70,000 PSI. The 1 stands for our position of the rod. And that would mean with this rod, I can weld flat, horizontal, vertical, and upside down. There's some rods like a jet rod, which is a 7024, that only you can do horizontal and flat because it puts down so much metal that if you tried to weld overhead, it'd just drip. It wouldn't actually stick. So the 1 stands for flat, the 2 stands for horizontal, the 3 is vertical, and 4 is overhead. So if it has a 1, that means it's all position. You'll never really see a 30 something. I've never seen that personally. You'll just see a 7024 or something other than 20, and that just tells you that do not try to do this to where it's not going to have gravity helping it stick. And then the 8 at the end is your composition. So that tells you what it's made of, like for example 5% chromium, 2% nickel, etc. There's a chart you can find that goes over all the ingredients in a rod, but that tells you the characteristics of what the rod is going to do. So the same thing applies to the 60 series rod, but you notice that there's a difference in tensile strength. So a 7018 is what in the industry call a low-high rod. So that means low hydrogen. So what does low hydrogen mean? Hydrogen is water molecules. So when you store these on a job site, you have to keep them in an oven, because if this gets any kind of moisture in it, it's pretty much done for. So the 7018's application is a structural supporting rod. So say, hanging an I-beam somewhere, building a skyscraper, 7018 is what they're going to use. Or they're going to use flux core, which is 7018, but in a continuous wire form. Okay. So high cellulose, which is a 6011 or a 6010. And as I said, today we're using 6011. So as this burns, you'll smell kind of a wood paper product kind of burn smell. And that's because it has cellulose in it, which is wood parts. So the high cellulose is more focused on penetration. So usually, say we had a lawnmower deck that was ripped or something, and you had a gap, you could take this 6011 and bridge the gap with it, and then go back over with a 7018 to reinforce it. So with a 7018, your metal needs to be pretty clean. You need to, and like with this metal, we have what's called mill scale on it, which is this gray kind of stuff, and that's just for storing to prevent corrosion. So 7018 and 6011 most stick rods can burn right through that mill scale. And 7018 can handle rust, and you're really not supposed to, but it can handle rust, it can handle some dirt, it can handle some grease. But
6011 can?
Yeah, 6011 will blow right through rust.
So it's more like a general purpose?
Yeah, so 6011 is your classic good old boy farm rod. 6011 is like if you go to your grandpa's welding shop, he'll have 6011.
You didn't have to have any special storage?
Not for 6011. For 7018, especially for what we're like y'all guys will be doing, you do not have to keep 7018 in an oven. Just keep it in a dry place, like put it in a Ziploc bag and make sure all the air is out of it. Like that's what I do with mine at home. I don't have an oven at home, but you know, up at the college and places I've worked at, we did keep it in the oven because a lot of it was X-rayed and non-destructively tested.
So on the 7018, if let's say you're keeping it at home, but you want to use it, is it a good idea to, prior to using it, stick it in the oven to dry it out?
You could. I don't. If it's been dry, I mean, if one gets wet, this will literally feel like gummy. This flux will.
It's just actually getting it wet. It's humidity.
It's impregnating humidity into it. It'll absorb it from the atmosphere stuff. So, just a quick recap. We're going to be going over SMAW welding today, which is also known as stick. I was going over the Polarity stuff and the two rods we're going to be using, but I can go over that more individually with you later on.
Dumb question. As far as the flux is concerned, are all fluxes the same?
They're not. That's a really good question. So that is a perfect segue into my next bit. So there's three main welding processes. So there's SMAW, GMAW, and GTAW. So shielded metal arc welding, gas metal arc welding, gas tungsten arc welding. Okay, so the GMAW is MIG. So you're using shielding gas. Unlike stick, that you don't have to have one because that flux turns into your gas. The GTAW is TIG. So with TIG, that's mostly of what my background was in the industry. But you actually have, it's a small torch and you have a piece of tungsten. And the reason we use tungsten is because it has an extremely high melting point. So you have argon gas that comes out and the electrical arc from the tungsten ionizes that argon and creates a plasma that burns at about 12,000 degrees. So you can get extremely precise. And another thing with TIG, your polarity is reversed. So it's actually straight polarity. So your electricity is traveling from your electrode to your workpiece. So you have a more focused heat affected zone, okay? And then with MIG, you said you've done MIG before.
Yep.
And you've done spool gun, which is very similar. So you have a wire drive that comes through a gun, and usually when you're talking about MIG, you're talking about short circuit MIG. There's all kinds of different kinds. There's spray transfer, globular transfer, on and on. But for you guys, I just want you, if you do more research, focus on short circuit MIG, because that's the most common. But the gas you use with that is 75-25, so it'll be 75% argon, 25% carbon dioxide. That may be flip-flopped, but it's one of the two.
Is that too, what does the gas do for you? How does it, I know in MIG it's to protect the metal and protect the rod.
So because it's an inert gas, it's a little heavier than our atmosphere. So it displaces our atmosphere. So I'm no chemist, but because of the way our atmosphere is, you know, hydrogen, oxygen, whatever, it impregnates itself into that molten metal and stays there as it cools. So by the time it cools, you have pinholes all through it. You can also have what's called worm tracks, which are little grooves. It's a defect. It makes your weld very brittle. But that's why we use inert gas. There's all kinds of different kinds. There's artificial ones like Stargon, but most commonly you'll see 100% argon and 75-25. So, I think that pretty much covers our basics. Is there any questions on that?